Now we want to graph some inequalities in two variables. And the steps that we're going to use I've written over here on the board. First, we're going to replace the inequality symbol with an equal sign. That will give us the equation of the boundary. Graph the equation from step 1 with a dotted line if the original inequality symbol was less than or greater than, and with a solid line if it's less than or equal to or greater than or equal to. You'll see when we get to the first example that this will make a lot more sense. But all these inequalities that we're going to graph will give us a region of the coordinate plane. The boundary for that region is what we get when we replace the inequality symbol with an equal sign. If the boundary is included in the solution set, we use a solid line. If it's not included in the solution set, we use a dotted line. Now we need to check and find out which region above or below the boundary line the solution set lies on, and for that we test any point that's not on the boundary in the original inequality and see if it makes a true statement or not. True statement means we're on the correct side of the boundary. False statement means we got to go to the other side of the boundary. But this makes a lot more sense when we actually do an example, so let's do that. I want to graph 2x minus 3y is less than 6. So 2x minus 3y is less than 6. And first of all, the boundary. The boundary line is 2x minus 3y is equal to 6. So I replace the original inequality symbol with an equal sign. Now this is the boundary and I'm going to graph it. But notice that this is a strictly less than symbol, so my boundary line is not going to be part of the solution set. That is, I don't want ordered pairs where 2x minus 3y is equal to 6. I want the ones where 2x minus 3y is strictly less than 6. So because the boundary itself is not part of the solution, I'm going to graph it with a dotted line. Or a broken line, you might say. So I want to graph this equation here very quickly. I'm just going to do it by graphing with intercepts. I'll let y be equal to 0 and see that x is equal to 3. So x is 1, 2, 3. That's this point right here. And when x is equal to 0, you can see that y is equal to negative 2. So y equal negative 2. So here are my intercepts for the boundary line. Now I'm going to graph the boundary line using a dotted line. So I'll line this up right here and then just use a dotted line like this. Okay, so there's the boundary. Now my solution set lies either in this region right here or in this region right here. And to see which region it is, I simply test any point in either one of these regions. So if any point over here is a solution to this inequality, then all the points over here are solutions, and none of the points over here are solutions. If any point over here is a solution to this inequality, then all the points over here are solutions, and none of the points on the other side are. So you want to make it easy on yourself. Here's a test point right here, the origin that's not on the boundary line, and it's an easy point to try. So I'm going to test 0, 0 in the original inequality. So 2 times 0 minus 3 times 0 less than 6, and that's a question mark. Is that less than 6? 0 minus 0 is 0. Less than 6? I get a true statement. A true statement means that this point 0, 0 satisfies this inequality or is a solution to this inequality. That point lies above the boundary line, so all the solutions to that also lie above the boundary line. So this region, from this dotted line on up, is the solution set for this linear inequality in two variables. So once again, the way I find it is by replacing the inequality symbol with an equal sign. That's the equation of the boundary. If this is strictly a less than sign or greater than sign, then I graph my boundary line with a dotted line. If this was less than or equal to or greater than or equal to, I would use a solid line for the boundary. Then once I have the boundary line, I just choose any point that's not on the boundary itself and test it in the original inequality. A true statement means I'm on the right side, the correct side of the boundary line. A false statement means I'm not on the correct side and I go to the other side. Okay, let's try another one of these. So here I have y is greater than or equal to x minus 5. So I'm going to start by graphing the boundary. The boundary line is y equals x minus 5. And because this is a greater than or equal to symbol right here, I'm going to use a solid line. for the boundary. So graphing the boundary, let's see, I'll graph when x is equal to 0, y is negative 5. 1, 2, 3, 4, 5. And when y is equal to 0, x is equal to positive 5. 1, 2, 3, 4, 5. So here I have y is equal to x minus 5. That's my boundary line. I want to graph it using a solid line. So I'll do that. Here's the boundary line. It looks like that. Now, next I need to test any point that's not on the boundary. Again, the origin's not on the boundary, so I'll test it. Let's test the origin 0, 0 in my original inequality. So I have 0 greater than or equal to 0 minus 5, and that's a question mark. So I have 0 greater than or equal to negative 5. Now, is this a true statement or a false statement? 0 greater than or equal to negative 5. It's a true statement, which means that the side that my test point falls on is the side of the solution set for this inequality. So again, this time my solution set lies above this boundary line. Now, if we were to choose a point over in this region and test it in the original inequality, we would get a false statement. None of the points in this region work, and all of the points in this region work. So as far as you making the choice of what point to use, you can't go wrong unless, of course, you choose a point that's right on the boundary itself. So you want to choose any point whatsoever, and there's an infinite number of them that are not on the boundary. You test the point, whatever you get, a true statement or a false statement, you'll know which side of the boundary the solution set lies on. If you get a true statement, you're on the correct side of the boundary. If you get a false statement, you have to go to the other side for the solution set. Okay, let's look at one last example. Y is less than 2. So y is less than 2 is my inequality. It has a boundary of y equal to, and since this is strictly less than, that boundary is going to be a dotted line. So y is equal to 2. That's a horizontal line that goes through y equal 2. So let me get my ruler here, and I'll graph that using a dotted line or a broken line. There's my boundary. Y is equal to 2. I want all the ordered pairs x, y where the y coordinate is less than 2. Here is all the ordered pairs x, y where the y coordinate is equal to 2. So I think you can see all the ordered pairs where the y coordinate is less than 2 are the ordered pairs that are down this way. So my boundary lies down below, my solution set lies down below this boundary line. And in this case, I can just reason out where the boundary is going to be, and I don't need to test any points. So remember, some linear equations in two variables show only one of the variables. This is y is less than 2, boundary y equal 2. That's this straight line that goes through y equal 2 on the y equal axis and is a horizontal line. So that's a look at graphing linear inequalities in two variables.